In this tutorial, we're going to implement a semi-supervised GAN from scratch in Keras. So, this article by Jason Brownlee, he implement the semi-supervised models for the images, which is 2D features. And on the left is I adjust his coding, and which the features is only one dimension. So let's check it out. So if you want to implement images, then you can look into his article, and he explained very clear. So on the left, I import the libraries here, and then I use a simple data set here, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 9 features with 1 labels. And then what we do here, because here is category features, so we just one hot encode it. So we have 15 features now, and then we split the data set first. So we have 76 testing samples, and then we're going to use the other 200 samples for training the GAN. And then as we can see here is we use the machine learning, so decision tree, logistic regression, and KNN with all of these features, and then we can see the accuracy is 73%, 76, 69. So why we predict these is because we want to compare with how good GAN is. And then here is a very simple deep learning with TensorFlow Keras, and then at last we have 73% accuracy. Now we start training GAN now. So the model here. So first we define the discriminator here. So discriminator, we have 2 models in discriminator. So when we input the in discriminator we have 2 models inside it. So the first one is C model, the other one is D model. So the C model is when the generator outputs the images or the fake features, and then the discriminator, the C model, will use these values and then predict the class. And then the D model here is it's binary cross here. So it's predicting if the generates the fake values is the generates value is fake or not fake. It looks like the same as the real one. So the first part is, as we can see on the right here, it's 2D CNN models, and then the last part is the left part is the D model, which is fake or not fake, and the right part is the class. So on the left I change it, and then I use this very simple deep learning TensorFlow models. So I just sigmoid, and then we add the leaky value. So the leaky value is as you can see here. So the leaky value is it allows a small gradient when the unit is not active. So we can see the line here. So So it allows not all the neural units that died. And like ReLU, you can see here, it's a y equals 0, so the neural units will die. And with it. So how is leaky ReLU? So we can see it here. Leaky ReLU, it allows a small gradient when the unit is not active. And then what does that mean? So we can see the line here. So this means the leak ReLU. So the degree is the alpha, so you can put the alpha in it, and then so it allows some negative So what is leaky ReLU? So leaky ReLU it's allow a small gradient when the unit is not active. So alpha times x for x smaller than 0. So we can see in a line. So it allows a small gradient of the ReLU, the neural units, and so the ReLU here is y equals to 0. So when the neural unit's dead, then it's dead. It won't comes back. But the leaky ReLU might make it comes back, because generator is that keeping generate something, but we're not sure that if the generator that features is correct or not. So we need some leaky ReLU to save some potential neural units. Yeah. So here is sparse categorical, and then here is binary cross-tree for the last layers. And then we are going to define the generator. So define the generator. So we're going to define the generator. So the generator here, it's going to output the feature. How many features is the generator going to output? So here it will be 15 features, because my dataset only have 15 features. And then if it's image, so he is going to output 28 by 28 image features. And then we combine the generator and discriminator models for updating the generator weights. So generator can keep learning from discriminator, and then generates more real fake values. And then here I'm loading the x and y here, and then here is we select the supervised sample. So here is the difference between mine and his code. So it actually is the same stuff here, because pandas is very useful libraries. So here is just like we put a data set here, and then xy, and then we just put a random set, and then just random the samples, the real samples here. And then on the right, his part is it's actually the same thing, but it outputs then the array here, the list array here. So my part is I output the pandas, and then generate the real samples. So same here, you use it same. So I do the same stuff here. I output the pandas data frame, and then generate pointing latent space as input for the generators. So it means how many samples are we going to use, and then we're going to generate the fixed samples. So when we generate the fixed samples, so we can make the new predictions. So for example, that after we training for the generator, so we going to generate the fixed samples for the by the generator, so we can do the semi-supervised machine learning here. And then now we just summarize the performance. We're going to save the models that we trained for the train generator here, and then here is just combine the above the models we put it here, and then now we can start run the model, start training the GAN, and then after after 10,000 training, and then I run because I save every 500 epochs, save the models every 500 epochs. So as we can see here, I run the model, every trained model here, and then let's see how we have the score here. So the 500 epochs, so the train accuracy 70%. So the train accuracy is the same, it will have the same accuracy as when we train the GANs here. So this is just compare the train accuracy and the test accuracy. So the test accuracy is never in the training process of the GAN, is separate at the beginning of this program, so we can make sure that because in a real life we want to predict unknown, so we just made the test accuracy unknown here, and then we can see the testing accuracy is getting better and better, and then we can see at epochs to 2500 we can get 80.263%. It's pretty good. And then after many epochs it become lower, so definitely the generate fake value is become overfitting, that is not making the machine learning overfit, and then get a very low accuracy here. Yeah, so if you have any question, you can leave your question in the comments, and because I learned GAN with this article on the right part, so I maybe have understood some parts. So if I have any mistakes, please leave your comments. Alright, thank you.